Alrighty, here we have section 4.2, which we're going to talk about sums and sigma notation. So we're going to be using some new stuff. With sigma notation, we use the capital Greek letter sigma as a symbol for a sum. When we write it out like this, a sum looks kind of like this. We have a few things. I is our index of summation. N is the total number we're going to. And if we take the term a to the I, that just means that I've got the first a plus the second a, so on and so forth until I get to the last number. So it looks like this. In this example, we're asked to write out the terms and then compute the sum. For this, we're going to have 6 terms, and we're starting at the number 1. So that means we're going to have 3, and then we're going to have 1 squared plus 3 times 2 squared plus 3 times 3 squared plus 3 times 4 squared plus 3 times 5 squared, and then our last thing is 3 times 6 squared. Alright, so if we do that, we end up with 3 plus 3 times 4 plus 3 times 9 plus 3 times 16 plus 3 times 25 plus 3 times 36. And we end up with we end up with 273. Alright, same thing here. We are going to write out the terms and compute the sum. So here we got to take a notice that we're starting at 6 and we're going to 10. So we start off with the exact same thing, except for we got a little bit more to do. We got 4 times 6 plus 2, and then we've got 4 times 7 plus 2, and then 4 times 8 plus 2, and we're adding 4 times 9 plus 2, and then 4 times 10 plus 2. Now, I'm not going to show you all of them worked out this time, but it does give us an answer of 170. Alright, so if you need to work that out to prove to yourself that that's how it works, knock yourself out. Oops. So, in order to make this a little easier, we have some rules. Alright, so we don't always want to write things out. So, on the first one, if we have a constant and we're trying to sum them up, we just pretty much take the number of terms we have at the top times that constant, and that gives us the sum of the constants. If we're just looking for a sum of the n first positive integers, we'll just have a variable there, our index of summation is just there, and it's just pretty much the number of terms times the number of terms plus 1 divided by 2. And if you want to see the proof of this, it's all in your book on page 357 is where they actually, the author of our book, does the proof of how this works and where these numbers, these expressions come from. If I'm doing the sum of the squares of the first positive integers, I do the number of terms times the number of terms plus 1 times 2 times the number of terms plus 1, and then divide by 6. So we're going to use some of these rules in a few examples. I think I skipped something, didn't I? This is going terribly. Oh, there we go. So we can split these up just like we did before with some other items. So all this is doing is taking the constant term out and then having term A and doing that summation, and bringing the constant term D out and doing this when we have a sum. So when we have two things put together in the middle, we can actually split our summation up into two parts, and that'll make some things a little easier as we go. What is this thing doing? I apparently put that in the wrong order. Alright, so for this example, we want to translate into summation notation first, and then compute the sum. So it says the sum of the squares of the first 50 positive integers. That means for summation notation, I'm going to write my sigma. We're doing the first 50 positive integers, so we're going to start our index at 1, and we're going up to 50. And then we're going to have I squared. Alright? So that's what we're actually trying to find. Now we had a rule to help us out with that, and that was just going to be the number of terms times the number of terms plus 1 times 2 times that number of terms plus 1. All of that is over 6. So pretty much we're going to do 50 times 51 times 101 divided by 6. And if you calculate that out, you get 42,925. Alright, same principle here. We're still using our summation notation. We're going to use our rules though, so we got to split this one up. Since we have the 3i minus 1, we're going from 1 to 70. I really don't want to have to write out 70 terms, so we've got our little rules. Let's break this up first. We got 3, and then we're doing the sum of the positive integers I, and then we're going to subtract the sum of the constants. So we got the constant 1 there. And this second part is really easy. We're just going to do 70 times 1. So we're going to subtract 70 times 1. The first one we've got to do 3 times, and then we're going to do our number of terms, 70, and then we're going to do 70 plus 1, and that's going to be over 2. Alright, so we're going to pretty much multiply 70 and 71 together, divide by 2, multiply by 3, and you should get 7,385. Alright, and again, I'm actually going to show you a little trick here in a minute to use Desmos to check your answers, because Desmos will actually do this summation for you, and you won't have to worry about typing it all in or calculating it all out and worrying that you did not get it correct. So again, we're asked to use some summation rules to compute the sum. So again, we've got 3 terms. We've got to split these 3 terms out. We've got the sum from 1 to 100 of the positive integers squared minus 3 times the sum from 1 to 100 of the positive integers plus the sum of the constant 2. For that 2, again, we end up with just 2 times the number of terms, which is 100. The first one, we've got the long format of 100, and then we do 100 plus 1, and then we do 2 times 100 plus 1 over 6, and then we get minus 3. I didn't give myself enough room. And then we got 100 times 100 plus 1 over 2, and then we got the 2 times 100. And through the math magic of calculators, you can figure out that this is 323,400. Now, you might say, hey, Mr. Harbison, you told me you were going to use Desmos to do this, so let me show you how to use Desmos to do this. Alright, on Desmos, there is a great function So when you load up Desmos, you go to your function button, and if you go over to miscellaneous, you might look down here at the corner and you'll see sigma. So we just got to type in our starting point at 1. We go up here to the top and we're going to make that 100. Now you might notice it doesn't have an I at the bottom. It has n. That index of summation could be any variable. So the book, the ones that we're doing, the problems have I, but it could be n, it could be a, it could be b. There is a little remark in the book on page 356 about that, so you can read that on your own. So here we got to remember we got to use n. So I got to use n squared minus 3n plus 2. And when I put that in, I get a different answer than what I told you, didn't I? I must have wrote down, no, that's the right number. So you get 323,400, which is the answer we expected. So you can do that on any of the problems using Desmos to check your work. You need to be able to do this stuff by hand because we're going to be doing more with this on Wednesday, where you have to do the summation by hand. So I'd rather you do it by hand and check your answers with Desmos.